Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at rate laws and how the rate law relate to rate constant, that is represented by the letter K, to the changes in temperature we know is measured in molarity over time, which is in seconds, okay? So now let's look at the structure of a rate law. Here we have this chemical reaction, A plus B plus C equal to the product D. And we look at the structure of the rate of a reaction or the rate law, we only see that we are looking at the changes in reactant, okay? So that's extremely important. Reactant only. And notice how we have your K, which is your rate constant. X, Y, Z are the orders respect to reactant A, B, and C. So each specific reactant has a specific order. Again, they are not necessarily the coefficient of the reactant. That's one thing you have to remember. And in a later lesson, we are going to learn how to solve for those orders. And that's the biggest challenge of this particular topic. Now, before we move into that, you need to be able to memorize specific facts about specific rate order. And there are three types. We are going to focus on the zero, the first, and the second order. They have very specific characteristics that you have to know, and you are given information on the test to identify if the reaction is zero, first, or second based on the data provided to you. First thing we have is the rate of the zero order reaction. Well, in this zero order, the rate is independent, and basically independent means it does not depend on the concentration of the reactant. As you can see here, the rate law. Notice how the concentration is to the zero, and anything to the zero power equal to 1. And that's why the rate is going to be constant. So if I look at the graph, okay, in terms of rate over time, and of course if it's constant, that means it doesn't change. So as long as the temperature remains the same, the rate will stay constant, okay? Now, another factor that we have to look at is sometimes they don't give you in this graph, but they give you in terms of this right here. And they love to give you in terms of concentration, okay? And that versus time. And what you notice, of course, so as you can see, so based on this, I want you to use a common sense. What happened to the reactant over time? And of course, what you notice, of course, there is a decrease of reactant. And here's a key thing. Notice this is a line. So as you can see here, your slope is equal to negative K. There you go. So that's one thing you have to remember. We are going to figure out how to solve the slope based on different specific order. So that is the zero order. Now we have the first order coming up next. It's basically in this specific order reaction, we have the rate is proportional to the concentration of one reactant. And here's the most important part about this right here is getting a little more factor information. So this is the rate law. You can see here the first order. But in terms of where is this equation derived from? It's coming from this right here. And this can be rewritten as y equal to mx plus b. So it looks very confusing so far, right? But think about this. We look at in terms of the graph, right? This is your time. And we can look at this in terms of natural log of a relative to t. T is again is time. And what you notice is that we can bring this over here, okay, we can bring this over here so that you can see right there, right? This is your B, this is your MX, and this is your Y. So you can see that right there. I kind of labeled that for you. And the challenge part is that we are going to give you a graph on your test, and you have to figure out what is the K constant going to be, what's the initial concentration going to be, what is the concentration going to be at a specific time by using this equation, okay? And of course, this is natural log right here. So that's natural log. So if I'm going to draw this graph out, we can see that we are starting at the values of natural log of the concentration of A at 0 second. This is 0 second. And over time, we have a straight line going down. So the concentration change over time. So this right here, your slope, of course, is going to be your negative K right there. So very, very careful, okay? You have to keep that in mind. So that's the characteristic of the first order. And of course, we're going to look at more carefully later on. Now let's move on to the second order. What you have here is that the reaction rate is directly proportional to the square of one of the reactant. You can see the second right there, the square, right, to the power of 2. And if we rewrite this reaction, again, y equal to mx plus b, you can see this is your b, k right here, that is your slope, and this right here is your y. So let's graph this, okay? And look at this. Notice how this is a positive slope, right? So that means it's going to go up this way. But let's do the basic stuff first. Time, and it's 1 over concentration of T. So it's going to change over time, okay? It's going to change over time. Now, look at this, where your B is. Before we draw the graph, let's look at this equation. Notice how we have a positive slope, right? Of course, we're going to have some kind of changes that are going up, positive and going up this way. See, that is positive slope. And of course, if that's the case, we're not going to be having the initial concentration over here, like up here where we have with the first order, but in down here we have 1 over the concentration of 0. It's going to be right there. And over time, we can see that the changes is going up, right? Again, you have to memorize this information, and that's the biggest challenge for you, because in the end, you are going to give different graphs and you have to figure out the slope, the concentration at a specific time, either using the graph or plug into the equation, okay? And here we have a table that's kind of summarize everything, but here's the most important right here. A lot of time you are giving your graph and you have to determine the order of reaction based on the graph. And notice how we have, for zero order, concentration versus time, you have a straight line. For first order, we have natural log of concentration, and 1 over concentration versus time is for the second order. So please take the time to memorize specific information about each rate order, because they are the heart of solving the more challenging problem in regard to reaction rate. And we see you next time on another exciting video.